Biswas, I welcome you all in my channel Chemistry, the Mystery of Molecules. So today's MCQ is in front of you. I request you please pause the video and try by yourself, and definitely after that I shall provide the right answer. I believe you have tried, so let me answer. So this is the question is in front of you. In presence of AlBr3, actually this fluorine is replaced. Okay, so four options are given. Which one is the right answer? Let's discuss. This is little different, student, so it will be very interesting. Let's see. So what is the product? If you look at the mechanism of the reaction, what happens? This AlBr3 is nothing but this is Lewis acid. Why? Because aluminium, in case of aluminium, you see there are 3 bromine attached, means outermost valence shell have 6 electron, means it needs additional 2 electron to fill its octet. That's why it acts as a Lewis acid. Fine. Now in this case it can coordinate with someone who has lone pair of electron and rich in electron. We know that fluorine is electron rich, point number 1, and another thing, fluorine is a second row element. So fluorine aluminium means fluorine, for example, have 3 lone pairs of electron. So this fluorine lone pair donation to this aluminium 3 center is very stable. So that's why fluorine prefers to donate. Now in this case what happens? If you look at this molecule, there are different kinds of fluorine. What do I mean? One is CF3 fluorine and others are aromatic fluorine. Logically many coordination possible. Okay, this everything, but we will focus mainly the coordination which will result in the product. Now if you look at little closely, that there are one, means this is a parafluoro, or there are orthofluoro, or there is a metafluoro, and this is the ortho, this is the meta. Now question, if you look at this ortho part, this ortho part is in close to this CF3. So coordination case you may consider that some bulkiness is there, but in this case major factor is not bulkiness, something else. But if you remove the bulkiness factor also, you can say that sir, this meta part is completely free, meta and para, so they can, but in this case you are showing that this para part is coordinating. Question, why? See, if you look at this, this CF3 group, these CF3 groups actually sigma withdrawing. Okay, this is sigma withdrawing. How? Because of attachment of this 3 electronegative fluorine atom, this carbon becomes electron deficient. That's why it withdraws the electron density from this sp2, means the phenyl ring. So it's a sigma withdrawing, and we know that sigma withdrawing effect works up to 4 carbons efficiently. Okay, so if you look at this is 1, 2, 3, 4, or you may differently, means if you go beyond of your count, means go far and far you go, for the extent of withdrawing effect will reduce. We understood. Now in this case if you look at this metafluorines, 2 metafluorines are facing relatively more electron withdrawing nature of this CF3 group, so consequently they are more electron deficient compared to this para one. On this parafluorine, means carbon fluorine bond or fluorine atom, the withdrawing effect of this CF3 group is minimum. Consequently we can say that this fluorine is most electron rich among these 2 meta and 2 orthofluorines with respect to CF3 group. Fine. Since it is relatively most electron rich in this molecule, so it will prefer to coordinate with this aluminium 3 bromide, which is Lewis acidic. Now after that what it produces, it produces an addact. Addact means these, in this case fluorine is having a partial positive charge after addact formation, and this AlBr3 having a formal negative charge, means fluorine having formal positive charge, AlBr3 formal negative charge. Now after that what it can do, this AlBr3 can remove or leave 1 bromine atom. You will say that sir, sometime before you were showing there were 6 electrons. that's its electron deficient, and if it leaves one bromine, then it will again become 6 electron. Yes, it's true, but why? Because to produce something which is relatively more stable, that's why the molecules will take this much extent of risk. Now in this case what happens? After that this bromine eliminates, so Br minus. Now this, what this Br minus does, this Br minus attacks here. How? This mechanism is called aromatic nucleophilic substitution. I have already discussed this thing previously, and not only that, preparation of hexafluorobenzene from hexachlorobenzene. In this case, such type of chemical reactivity you can observe. Now, in this case, you will just say that, sir, previously we have seen aromatic nucleophilic substitution on different nucleus. What do I mean? For example, 4-nitrochlorobenzene, where the nucleophile will attack here, and through the resonance the negative charge is stabilized due to the nitro group, and that's why this aromatic nucleophilic substitution happening. But in this case, no groups are present like this nitro, which has both minus I and minus R. In this case, on these fluorines have minus I and plus R halogen, and this CF3 has only minus I effect. So how this reaction is happening? Because nobody have this minus R effect. If minus R effect absent, how this negative charge is stabilized? Remember student, actually negative charge means excess of electron. So this is actually excess of electron, and we need someone who will delocalize this excess of electron. Remember that halogens have both minus I effect and plus R effect, and always this minus I dominates or contributes more compared to the plus R. Means in conclusion, they are actually withdrawing. So if when any negative charge will be produced after this attack, means here all this negative charge will be delocalized all over the ring, and these fluorine atoms will stabilize by its minus I effect. Not only fluorine, this CF3 group also. Why? Because the electronegativity of CF3 you can consider, this is in between, means near about fluorine or oxygen, like means oxygen, nitrogen, like that, significantly high withdrawing. So consequently, it means that because of the presence of this many withdrawing groups, the negative charge is stabilized. That's why aromatic nucleophilic substitution on this nucleus is possible, and after this substitution it produces this bromo derivative. I am not showing any mechanism in details because I have explained it previously. Now, so in this case it will produce this Br. So this is the answer. Okay, so answer of our question is the para derivative, means option C. Now you will say that, sir, you are saying this option C is the right answer. Sorry, not option C. In this case only para bromo, sorry, this is option C. Now you can say that, sir, you are showing this option C is the answer, why not others? First of all, why not ortho? Because coordination of this fluoro to the aluminum center is difficult. Second, it will not have any fate because that second bromine minus can't attack the benzene ring. So second step not possible, that's why this is not possible. Point option can. Now here multiple, and here also, sorry, in this case this is a meta substitution. I have told that this meta fluoro is not that much electron rich compared to the para, that's why para will prefer to donate its electron density to the aluminum center. So in this case we can conclude that this option B not possible, while not option D. So in this case multiple substitution happens, which is not possible. Why? See, after this reaction the product along with C, what it produces? AlBr2F. Okay, so if you look at this molecule, in this case this F has 3 lone pairs of electron, so consequently through back bonding it can donate more efficiently to the weak and p orbital of aluminium. Okay, so this is the interesting thing. Consequently, if you compare this F, this part with AlBr3, AlBr3 is more electron deficient. So this is more electron deficient. since the more electron deficient thing is already consumed because of the fluorine, so now the secondly produced product is not that much electron deficient. That's why it is not capable to undergo further bromination or bromine substitution reaction. Okay, so generally during our organic chemistry learning, we always focus on the organic product what we got, but we never focus the what the other part we focus. So that's why student, it is important you should focus the overall reaction, not a particular product. So in conclusion, what you have learned today, aluminum 3 plus is a Lewis acidic, and in this case fluoride minus can act as a Lewis base because of its lone pair of electron. So donor acceptor complex formation possible. New Lewis acid, that is AlFBr2, is relatively less electron deficient, so less reactive than LBr3 for such kind of aromatic nucleic substitution and overall replacement. The reaction condition doesn't allow multiple bromine attachment. I have explained why. And the CF3 group is withdrawing, but fluorine means CF3 group is only sigma withdrawing, but this fluorine is sigma withdrawing and pi donating. That's why, that's the interesting thing. Actually, that's the reason. If you see, this carbon fluorine bond is one of the strongest, although it's strongest, but still it's replaced by this bromide. And CF bond is strongest covalent bond in the organic chemistry. Just I told, this carbon fluorine bond you may consider like CF4 is the most stable carbon tetrahalide, and I have already discussed an MCQ on this. So this is the end of the discussion. I believe you have learned a lot. Thanks for watching. If you really enjoy my teaching, then please help my channel to grow. See you in my next video. Bye bye.